We are going to be looking at functions and graphs today a little bit. There's some new stuff to it. There's a lot of old stuff, so hopefully the new stuff isn't too hard and the old stuff is familiar. The values of one variable often depend on the values for another. Okay, this is just some examples of functions. Temperature at which water boils, and altitude above sea level. So one of those is dependent on the other. Which depends on which? Does the temperature depend on the altitude, or does the altitude depend on the temperature? Yeah, temperature depends on the altitude, right? This is like this is grade 10 again, actually. It's independent versus dependent. So that means that the independent variable there is the altitude, and the dependent variable is the temperature, because when you go up a mountain or whatever, right, the water boils at a lower temperature. It's not like, you wouldn't be like, oh, how quickly is this water boiling? That's how high I am off the ground. That would be weird. So it's the other way. Now your savings and your interest rates, right? Like your savings, how much you save, depends on what your interest rate is. That means that saving would be the dependent variable, and interest rate would be the independent. Now, which variable is which? The dependent variable, is that x or is that y? The y. Y is dependent. X is always independent. That's why x, it always goes on the horizontal axis. And same thing with these other ones, right? The area of a circle depends on the radius. Your shoe size might depend on your age. Like, not forever. Like, it's not like when you're 40 that changes your shoe size. But as you get older, starting from babyhood, your shoe size will change as you age. Okay? So we call one variable dependent, one independent. You guys know this already. In a function f of x is the independent, and f of x is the dependent. So remember, f of x, I don't like to say it's y, but it's very similar to y, right? F of x goes on the vertical axis. It's just a way of naming a function and telling you that it is a function, which is nice. Does anyone remember what a function is? Like, what's the definition of a function?
For every x value, there's only one y.
That's right. That's the actual definition of it, is that for each x value, there's only one y value. So you would say it would pass that vertical line test. That's a function. Okay, so that there should only ever be, if I tell you x is 5, there's only one option for y. Okay, you're not like, oh, well, at x equals 5, y could be 6 or it could be 9. Okay, then that's not a function. Okay, so you guys all know this too. X values are the domain, y values are the range. Okay, so all the x values in a function, that's what domain is. People tend to have a lot of trouble understanding what domain is when we learn it in grade 10, and it continues to be an issue for a lot of people till they graduate. But domain just means all the x values on a function. That's what the domain is. It's every x value on a function. The range, same thing, it's every y value that's on a function. So if the y value gets to 10, like if the graph ever hits 10 on the y axis, then 10 should be somewhere in the range. Okay. So a function from a set D to a set R is a rule that assigns a unique element in R to each element in D. That's just exactly what Ryan said. So don't worry about that definition too much. It sounds more complicated than it is. It's just that each x only has one y. Oh my gosh. How do I? Oh. Here. Sorry, they updated this app without asking me, and I don't know where all the new buttons are. Okay, so here it wants us to identify the domain and range and sketch each function. The sketches can be kind of rough. Let's what does 1 over x look like? Does anyone know offhand what 1 over x looks like? Yeah, like that. Okay, exactly like that. What Akash just did with his hands. So it's like, oops, it's like this, and like that. Hey, does anyone remember, okay. Does anyone remember what we call, in this case, it would be the y-axis is a line there. Does anyone remember what it's called? Asymptote. Perfect, great. Okay, so everyone's actually learned that because that's in 20-1. So everyone has seen asymptotes at least a little bit before. There's more of them in 20 or 30-1. So that's what that graph looks like. So for the domain and range of that thing, if I'm writing the domain for that, for x, y equals 1 over x, the domain for that one would be, oops, it's exciting, domain would be, and okay, this is important too. In calculus, we tend to use interval notation. You can use set notation if you really want to, but we tend to use interval notation, so that's what I'll be using. You've seen it a little before, at least, especially if I taught you any point. I'm always careful to do both. But Whatever you're most comfortable with is fine, but get used to interval notation for tests and stuff for multiple choice. They will be in interval notation. So interval notation is the one that looks like this. So if I was talking about the domain of this, so it goes like where it goes on the x-axis, what's the lowest it gets on the x-axis? Negative infinity. It's going towards negative infinity. It's like never gonna, it's going on forever. Okay, positive infinity as well, right? It's going all the way to positive infinity. But there is a problem in the middle. 0. It never touches 0. So the way we would write that with domain is we would write it goes from negative infinity up to 0. And then you put a u, which means union. And then it goes from 0 to infinity. Okay? So this is interval notation. It's like you're literally saying like it goes from this lowest value to this highest value. Okay? And usually it's just that it's like lowest highest. But in this case we have a hole in the middle. That hole in the middle, the 0, means that we have to put that in there. We have to say it goes from negative infinity to 0, then it skips 0, and it goes from 0 to infinity. Ryan?
Do you have to use the square brackets?
So this one would be soft brackets because it never actually touches infinity, so that's a really good question.
But on the other side?
No,
It never touches 0.
it never touches 0 either.
You have to use the square ones.
If it touches, yeah. So just to clarify, just for anyone who's maybe not super familiar with this notation, the soft brackets means it does not include it. So soft brackets here, there's soft bracket around 0 because it doesn't include 0. Okay? It never touches 0. Whereas a square bracket, if I used a square bracket, it would mean it does touch 0. Okay? So we'll see, at least one of these will have a square bracket in it, so you guys can see. Okay, and the range for this one is exactly the same because similarly with range, it goes down. It's going all the way down. I can see it's headed downwards. And it goes all the way up, but it never touches 0 as well. It has a horizontal asymptote as well. So my range for this is exactly the same. Negative infinity to 0, union 0 to infinity. Okay, so it's exactly the same. Okay, cool. Easy enough, right? Then, so let's look at the next one. It's not going to let me erase it. Of course not. I don't really understand the eraser function in this. Like if you click anything else, it doesn't let you erase anymore. Anyway, we'll do it in blue for fun. The square root of x. Here, maybe I'll even turn off some of the lights. Square root of x, what does that look like? Sort of like a sideways parabola, except it's because it's only the positive square root. It's only going to be the upper half of the sideways parabola. Okay, so it is like a sideways parabola, though. That's a great description. So it looks something like that. Okay, so it's this graph right here. Okay, so for that one, if I'm looking at domain, and this is really how I do domain when I'm doing it myself. I just think, what's the lowest value on the domain? What's the furthest to the left that this graph gets? 0. Starts at 0. Okay, and it goes up from there. Do you think it actually touches 0? Yeah, because you can take the square root of 0, right? If you plug 0 into that function, if I plug 0 and I do root 0, it'll give me 0. Starts at 0, 0. Okay, now if I plugged in a negative value into there, what would happen? It would give me an error because you can't take the square root of negative. That's why there's nothing to the left, because you can't have anything that's negative. So it starts at 0 and it actually does touch 0. So it's square bracket 0. And what does it go up to? Infinity. Perfect. Thank you, Sean. Okay, and infinity is always soft bracket. Always. Because it never ever touches infinity. Infinity is just something you approach. Okay, and range, again, is exactly the same, because it does the same thing on the range. Okay, so easy peasy. Hey, let's just do, I'm not going to do the very last one, I'll just do this next one. Actually, maybe, nah, I'm not going to. Well, let's just do the next one. 4 minus x squared, the square root of that. Does anyone have an idea of what that looks like? No, that would be a cubic. Would look like that. It's okay. Does anyone have an idea?
It would be flipped upside down and over.
Try to do transformations. Smart. No. You're wrong, but you had a good idea. There was nothing wrong with your idea there. Okay. This would actually be a semicircle just above the x-axis with a radius of 2. Okay, so this is actually a form that being familiar with is helpful. It's like There used to be a whole unit in Math 30 about conics, which you'd learn about this stuff in. They took it out years ago. And so you have never seen it before. But this in particular is a useful one, is if you see something like this, the form r squared minus x squared is a circle. Okay, if you take the square root of r squared minus x squared. So 4 is 2 squared. So I know that this is a circle with a radius of 2. Okay, but it's only the positive part. If I did the negative, it would do a full circle. Okay, if I did positive and negative. So it's just like that. So this one has an interesting domain and range because it actually like ends, right? So the domain is from -2 to 2. And what would the range be? 0 to 2. Okay, so don't overcomplicate this. Okay, you know, they're fairly simple. If you have trouble with domain and range, you're not alone. There's always at least a few people who just like never got domain and range. Like they've made it here to this place now in their lives, but they don't get it. That's okay. Please just talk to me. We can continue to discuss it. It's like, there's only so much you can do with it, I guess, but it's not too late for you. You can still figure it out, I swear. And it'll make 30-1 a lot easier if you do understand it, if you're taking 30-1 right now, because there's a lot of talk about this, and the teachers usually just kind of like just like I did, we just kind of like quickly go over it, and the assumption is everyone understands, because it's used in grade 10 and 11. And so your teacher probably won't spend much time on it, but it's going to come up like over and over and over again, so every unit you're going to feel like there's something you just don't quite get if you don't understand this. But interval notation's awesome. You can use it in 30-1 as well, just so you know. Like if there's nothing, if it's not stated which one you have to use, it's totally acceptable to use interval notation. In calculus, it will mostly be what we use. Okay? There might be the odd question that features set notation, and if that happens, you know, hopefully you understand it, but set notation is the stuff, just in case you're like, I have no idea what you're talking about. Set notation is like this stuff, where it's like x is greater than 2, where x is a real number, like that. Okay? Okay? Uh-huh. Yeah. 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 Yeah, that means that the function is defined on x such that. That line means such that. So it's saying it's using the variable x such that x must be a like greater than 0, or x must be an integer, or x must be, and they're telling you whatever the restrictions are in x. Right? It's just like a notation, right? Okay, guys. So this is the new thing. Haley. Okay? This is the new thing today that you've never seen before. And it's not super hard, to be honest. Some of the algebraic part of it is a little hard, but I want people to just understand the bigger idea of it. It's the difference between an even and an odd function. Now, this is not the same as even and odd functions in Math 30-1, where you're talking about, like, you know, quadratics are even, cubics are odd, quartics are even, syntix are, you know, like quintics are odd, and going on that way. This is different than that. It's not like even functions all both end upwards or what, you know, whatever. There's no rules like that. This is talking specifically about symmetry. Okay, so this is about symmetry, and there's two different types of symmetry that we look for. This actually, I don't know why, to be honest, I have no idea how it super relates to calculus, but it's on the AP exam all the time. I don't know why, because I don't think it particularly relates to limits or anything, but that's fine. Even functions are functions if f of negative x is equal to f of x. Now let's talk about what that means, because that means nothing to most people. So if we're talking about f of negative x equals f of x, okay, let's talk about what that would look like. So on a grid, okay, if you have a grid, okay, and I'm talking about f of, let's say I have a function, I'm just going to draw it here, okay, a beautiful function, okay, look at that, okay, and I tell you f of 2, oh my god, f of 2, what does f of 2 mean? 2 on the graph, what's 2, is that the x or the y? That's the x value, f of 2 is the y value. So what this would mean is, like, if I'm looking at, like, 2, it would be like, okay, I'm going to go over 2, and I'm going to look to see what the value is. So let's just say it's negative 3. Okay? Now, what this definition said is that f of negative x, if it's even, should equal f of x. Okay? So what that means is that f of negative 2, if it's even, should equal what? No. Negative 3. They should be equal to each other. Not like they should be flipped, but like that whatever I have, f of anything, so f of 2, should equal f of negative 2. Okay? They should be the same. So if I look backwards, and I go back to negative 2, is it the same value? Because I mean, it's not perfect, but I tried to draw something that looked even. So it is, okay? So an even function has a pretty easy type of symmetry to look at. Okay? It's telling you it's going to be the same on the left side of the x-axis as it is on the right side. That's what it means. Even though the algebra, kind of the notation of it looks a little funny, it's just saying left and right have to be the same. So if I look at, oh my gosh, this is, what's happening? Get out of here. How do you man. Nope. I'm gonna have to learn these new buttons. Oh no, I don't want to delete that. Ah, all of it. This is terrible. Okay, there we go. Okay, so if you look at that, even symmetry really just means it's symmetrical across the y-axis. And you know, hopefully what symmetrical means, right? Everyone knows that word? Everyone's familiar? Okay. It's like ideally your face would be symmetric. Not necessarily though. Okay, so odd symmetry is harder. Even's pretty easy to spot. Like if you look at a graph, the easiest way to do this is just to look at the graphs. Okay? If you have a calculator, that's super easy. If you don't have a calculator, you need to kind of have an idea of what graphs look like. That becomes a lot harder. So otherwise, you can always test it out using these rules. So you should know that even functions, f of negative x equals f of x. Like you should kind of have this memorized. Okay, like you should have these. Now odd functions is that f of negative x equals negative f of x. That's harder. It looks like this down here. This is just a cubic function. What it is we call it rotational symmetry. It has rotational symmetry, like back from grade 9. If I span that graph around, like this one down here in the corner, this one, okay? If I span that around, like in a circle, it would be back to itself, okay, about the origin. Okay, so that one's a little harder, but we could test it out too if we wanted to, if that was what we wanted to do. So to test it out though, think about it. If you have a graph, like let's say just x cubed, because that's a pretty easy graph. Okay, it says that negative f of x is equal to f of negative x, right? Is that what it says? Cool. Okay, so if we test this out, we can test this out with x cubed. I'm like negative, okay, so let's just look at f of 2. Let's use x equals 2 to test this out. Okay, so negative f of 2 is equal to f of negative 2. And let's check if that's true. So negative f of 2, if I want to do that, right, f of 2 just means you plug 2 in. That's all it means. Like, don't overcomplicate that stuff. Some people have a lot of trouble with that. All it means is I'm plugging 2 into x. Okay, so it's going to be negative, and then if I plug 2 into x and I do 2 cubed, what do I get? It's not a trick. 2 cubed. No. Not 9 either. It's going to be 8. Perfect. Wow, you guys are sharp today. Okay, and then if we do the next one, which is f of negative 2, that means plug negative 2 into this. So I plug negative 2 into x cubed, which is negative 2 cubed. I'm terrified to ask that question. Negative 2 cubed is also, believe it or not, negative 8. Okay, so they are equal to one another. It's lagging. I don't know why I was doing this yesterday too. Okay, so negative 8 equals negative 8. So this works, and it is odd. Okay, it's not even. Like if I tried this out to check if it was even, like if I plugged in negative 4 and positive 4, they wouldn't be the same. Obviously, they wouldn't be the same. Okay, I'd look at them, they're obviously not the same. Okay, so that's an odd function. And that's how you can test an odd function if you want to test it. But really the easiest way is just to kind of look. Yeah, so it has to, one easy thing with this type, with odd, because people have trouble with odd usually, is that odd symmetry, it has to go through the origin. Like if it doesn't go through the origin, it's not odd. Okay, it can't be. Like if I transformed this, if I just moved it up one, if I like brought the whole graph up one, it wouldn't be odd anymore. Okay, so anyway, let's just check it out. X squared, is that even or odd? Even. Okay, it says even or odd, or neither. I'm just gonna put that in there. Okay, x squared plus 1, is that even or odd? Or neither? What does x squared plus 1 look like? 1 up, that's right. So it would be x squared, but it'd be like this. So would that still be symmetric about the y-axis? Yeah, so that's even. Now what about x, the graph y equals x? Odd, that's odd. Okay, that one's pretty obvious, because if you draw a line, you know, it's like right through, it would be, if you span it, it would be exactly the same. And what about x plus 1? Neither. That one's neither. It's a trick. Okay, because if I put it up there, it obviously wouldn't be. Okay, it's pretty rare that you really have to test values. Most of the time, they'll be pretty straightforward graphs. I won't throw you any that you haven't seen yet. If, so people who are in 30-1 right now, don't worry. I won't be like, hey, is a logarithmic graph even or odd? Like you've never seen one. So I won't do that to you. Or at least I'm not expecting you to be like have it memorized. But by the end of the course, you are supposed to be familiar with all those different types of functions and have an idea of what they look like. So you should be able to say. Anyway, pretty easy though. I'm not going to do wise right now. I'm going to come back to that and do it tomorrow. I am going to do composite functions. Composite functions, those of you who are in 30-1 right now haven't really seen them yet. You will see them pretty soon though, like in the next couple weeks. And it's really important that you understand them, and they're not that hard once you get it. So hopefully this will help you in 30-1. Okay, if you're 30-1, you should learn it in a couple weeks. So f of g of 2, composite functions are like a function inside of another function. Okay, so like we are plugging in one function into another function. They're a little tricky at first. Now there's two different notations. So the notation is either like this, that's up there. So that's like if I'm plugging g into f. Like I'm taking g and I'm plugging it into f. Or sometimes it's written like this. F-O-G, this like, it looks like fog. That also means f of g. And it's read as f of g, that's how you would say it. Okay, so here's one, and I'm going to do some more. I'll do some more on the board afterwards. But f of g of x, if g of x equals x squared and f of x equals x minus 7, find f of g of 2. Okay, so f of g of x. Ooh, whoops. Okay, f of g of x. So that is, g of x is just x squared, right? Does everyone agree with me on that? It says g of x equals x squared. So all this means is it means f of x squared. Okay, now whenever something is in those brackets next to f, all it means is you plug whatever that is into x. Okay, even if it was like a picture of a rabbit, you would plug that picture of a rabbit into x. That's what you would do. Okay, that's what it means. So where I see x in f of x, so f of x is x minus 7. Where I see x, I'm going to plug in x squared. So instead of x minus 7, what will I have? X squared minus 7. And if there was a picture of a rabbit, it would be picture of a rabbit minus 7. Okay, like that's all it means. So whatever is in those brackets, you just plug it in to where x is. And that's what a composite function is. Okay, it's really not much more complicated than that. People have a lot of trouble with them. I mean, this is an easy one. I'll maybe show you some harder ones in a minute. But that is basically what it is. So f of g of 2, there's more than one way to do this. You could plug the 2 into g first and get 2 squared, which is 4, and then plug 4 into f. You could do that. Or you can just use this new equation we wrote and plug 2 right into it. Okay, it's up to you. So that's probably easier once you have the equation. So I would just plug 2 into that. 2 squared minus 7 is negative 3. So it's negative 3. F of g of 2 is negative 3. Alternatively, I could have plugged it in here, gotten 4, then done 4 minus 7, which is obviously also negative 3. You can see how they'd be the same thing. Okay, so that is a composite function.